Okay, in this video we're going to do the Ryken Geometry Final Review, and we're going to go over 5.2 and 5.3. So let's look first at 5.2. So 5.2, it says in Figure 3, CD is the perpendicular bisector of AB. So if it's a perpendicular bisector of AB, that means that you get a right angle, which I have by the box right there, and the bottom is bisected. Those are the two things that happen when you have perpendicular bisectors. Okay, so we have that understanding. Okay, so question 11 says, what can you say about AD, which is right here, and DB? So what happened? When they got bisected, they were cut exactly in half. So what you can say is that they are congruent. Okay, that's just symbol for congruent. Okay, let's go on to question 2. And question 2 in this section is actually question 11. So we're going to do that in gold. So if CA is 5, okay, so I have this situation still going on with the pink. That's still true. If CA is 5, what can we say about CB? Well, when you have a perpendicular bisector, what happens is you form two congruent triangles. Okay, here's the first triangle right there. And here's the second triangle. If they're congruent, what do I know? Well, what I know is that the sides, 5 and question mark, will be the same value. So we can say that if they are if I have a perpendicular bisector, then if CA is 5, then CB is also 5. So that's what I know happens when I have a perpendicular bisector. Okay, so let's just go over that a little bit right now. I'm going to erase what I have. So I'm erasing all of this, and I'm going to say, okay, certain things are going to happen. Okay, the first thing that's happening is that I have a perpendicular bisector. This happens as a result. These two are equal, and I have a right angle. Okay, so I know, for example, if I have a right angle for CDB, I have to also have, a right angle here at ADC because they're on a line. So if that's the case, then I have two right triangles back to back. They share this common side. So you can prove by side angle side congruency that those two triangles are congruent. This is the underlying theory. If those two triangles are congruent, then other things happen. These sides are equal. Okay, what else happens? These angles are equal. And these angles are equal. Because congruent parts, corresponding parts of congruent triangles are equal. So having the perpendicular bisector sets in motion several other things that you have to understand. Okay, so think about that. You can pause the video now. I'm going to erase what I just wrote so my picture's not so busy, and we will continue with the lesson. All right, so I'm looking at now question 13. So question 13 is going to be in this color. Okay, if CA is 3x plus 1 and CB is 7, what does x equal? Well, you have to remember that you have a perpendicular bisector. That's going to make two back-to-back congruent triangles. So piece AC will equal piece CB. So if you're going to do question 13, you can set those equal. So CA, well, let me backtrack for a sec. Okay, so what I know is that CA will equal CB. So if CA is 3x plus 1, and if CB is 7, can I solve that problem? And the answer is yes. So you're going to subtract 1 from each side. When I do that, that 1 goes. That becomes a 6. And I'm just going to rewrite it over here. So I get 3x equals 6. My goal is to solve for x. X will equal 2. So let's make sure that makes sense. If I plug x in here, 3 times 2 plus 1 is indeed 7. So they're both 7, so that works. Okay, think about that, because I'm going to need to erase some of this work in order to go on to the next problem. Okay, so let me just get rid of that stuff. I'll leave the answer there. Okay, so the answer there, the answer was, what does x equal? And the answer was x equaled 2. Okay, let's go on to the next problem. In the next problem, we'll do in green. It says if CA is 5, so label this 5, and AD is 3. Oh, interesting. What does CD equal? So we'll put a CD of x. So what do you know? You know Pythagorean Theorem. So Pythagorean Theorem is a squared plus b squared equals c squared. So that means the legs, which are the 3 side plus the x side, squaring each of those has to equal 5 squared. Okay, what happens next? Well, if I subtract 3 squared from 5 squared, so I'm just going to continue here, so x squared will equal 5 squared minus 3 squared. And x, which is what I'm looking for, because x is the CD, x will equal the square root of, that's square root, 5 squared minus 3 squared. X equals the square root of 25 minus 9. We'll continue up here. X equals the square root of 16. Okay, so what is that? If you put that in your calculator, you will see that x equals 4. Okay, because 16 is a perfect square. So the answer is that x equals 4. Okay, and I can leave that work there. Okay, we're going to go on to 5.3, but you may need to go back and look at your notes for 5.2 to make sure that you understand this question, because this question or something like it will appear on your final. 5.2 is an important section, just like 5.1 was an important section. You also have a Chapter 5 test and a Chapter 5 test review that you have amongst the items that you can use to study from for your final. Okay, 5.3 is the angle bisector theorem. So I give you information about that in the blue. So it says BE is the angle bisector of angle CBA. Okay, so what I'm going to do is, if BE is an angle bisector of this angle, then that means that this piece equals that piece because it's been bisected, which means cut exactly in half. Okay, if the length of BC is 7, what is the length of BA? So what do you need to figure out? Well, let's see what I have. I know a couple of things when I have an angle bisector. If this angle here, okay, so the top angle right here, so the one that's written in red, if that angle is equal and I have a right angle, what I'm going to tell you is that angle bisectors form angles that are isosceles, that have equal sides on the outside. So whatever this outside is right here, this is going to be the same outside. Okay, so if I know that BC is 7, then I know also that BA is 7, and that's part of the angle bisector theorem. So to understand why that works, I want to think about what's happening here. This little piece down here is key. When you have a point on the angle bisector, okay, this is the angle bisector right here. If you take this point right here at E and you draw a perpendicular line here and here, then this equals this. And I already know that I have a right angle, so I'm starting to get things equal. You can end up proving that if the red angles are equal and I have right angles, then because there's 180 degrees in a triangle, then these angles must also be equal. Okay, so this is how the theorem is building. So by angle, side, angle, okay, angle, side, angle, I can prove I have two congruent triangles. Once I have two congruent triangles, all the corresponding sides are equal, and that is why CB equals BA. Okay, so there's a lot to remember, but I want you to go back and think about that. Okay, I'm going to pause the video for a second so I can erase my picture. So I want to answer 16 and 17, and I don't want my picture to be cluttered. Okay, using orange, we're going to talk about this next one. So if angle CBE, so CBE is this angle. Remember, because I have an angle bisector, these two angles are equal. So if angle CBE is 42 degrees, okay, so if this angle right here is 42 degrees, what is the measure of angle ABE? So ABE is this angle right here. Well, that's the other half of the bisected angle. So if one is 42 degrees, the other must be 42 degrees as well. Okay, so then 17 kind of builds on it, so I think we can keep the same color. If angle CBE, so CBE, this is still 42, what is the measure of angle CBA? All right, look at this. CBA is the whole big angle. If each piece of it is 42, then the whole thing must be 42 plus 42, which is 84 degrees. So make sure that makes sense to you. We're going to go on the next page and just do question 18. So I'm going to pause this for a second and get to the next page. Okay, so I filled in the answers for questions 15 to 17 that we had on the previous page. I also want to indicate that this angle equals that angle. Okay, what else do I want to say? Based on our discussion in the previous page, I also know that this equals this. And I know that this equals this. All right, so these are the things I know, and I'm doing this as a pre-thought process for question 18. Question 18 says, if CE is x plus 11, Okay, so CE. So this right here is CE. So if that piece is x plus 11, and EA, okay, here's EA right here. EA is 3x plus 1. What's the value of x? Well, set those two pieces equal. I say I have 1x on the left side and 3x is on the right side. So I'm going to subtract x. That's going to be gone. Subtract x and then rewrite my problem. So now I have 11 equals 3x minus 1x is 2x plus 1. Okay, so this is a two-step problem. Let's keep the numbers on one side and the x's on the other side. So we're going to subtract 1, and that gives me 10 equals 2x. Divide by 2, and the result is that x equals 5. So that's my answer for x. Now let's check it. So I'm going to change colors so I can just check. This was x plus 11. If x is 5, 5 plus 11 is 16. This was 3x plus 1. If x equals 5, 3 times 5 is 15 plus 1. It's also 16, so it checks that two pieces are equal. So x equals 5 is the correct answer, and that completes the review of 5.2 and 5.3.